Hi everybody, welcome. So we're going to be helping you optimize problems. So first of all, what does it mean to optimize? It means to find the minimum or maximum of a function. So there are different steps involved, and we're going to be demonstrating this with an example, and we're going to be showing you this example right here in the corner. Now, the first step to optimizing a problem is to determine the function that needs to be optimized. So you'll have to read the question carefully and see if they're discussing area, perimeter, volume, cost. Now, in this case, let's say we're looking to optimize the area. So the question says, find the maximum area of a rectangle. So you know that area is equal to length times width. So you can see that right here. Now, in order to help you solve this, there's usually another constraint that follows in the question. So in this case, let's say the question says that the perimeter of the fence adds up to 200 meters. So you know that if you take all the sides of that perimeter, they're going to equal 200. So in this case, 2L plus 2W is equal to 200. Now try to read the question carefully and look for these clues. So it's good that we now have two equations, and we're going to use those to help write everything in terms of one variable. So we know that our function is the area, and we know that we have to take the derivative in order to find its minimum or maximum. Now, we have to make sure that all the variables of the area are actually written just in terms of one variable. So if there are two, we have to turn it into one. In this case, we know that area is equal to length times width. So there's length and width, 2. But we can use the perimeter equation to rearrange it and then substitute that rearrangement back into your area equation so that everything is in terms of, for example, W. So let's do that together now. So if we have 2W plus 2L is equal to 200, why don't you take a second, simplify that down, and write it in terms of W. So if you say L is equal to what? Because we're going to take that L and substitute that back into area. So we're going to pause right now. Okay, welcome back. So hopefully you've arrived at L is equal to 100 minus W, as you see here. So if you take that and plug that back in area, you're going to be given 100 minus W times W. So if you expand that out, you'll be given your new function, as you can see here. And now we're going to be taking this derivative. Now this is step number 4. So take the derivative. So how do you take the derivative? Follow the steps. Let's pause it, and then we can follow the steps. Okay, so hopefully you found the same derivative as the one that's shown right here. So a primed of W is equal to 100 minus 2W. And now we can set that to 0. Why are we doing that? In order to help us find W, and that's step number 5. So W is equal to 50. So what do we do next? Now that we found one dimension, we'll be able to find the next one, and that's L. So if you take W equals 50 and you plug that back into the initial perimeter equation that we used earlier, you'll be able to find L. And in this case, L is equal to 50 as well. So now we have step number 5, which is finding W, and step number 6, which is finding L. We can move on to the last step, and that's finding the second derivative of the area function. So why don't you try that yourself and check if we have the same answer. Okay, so hopefully you found the same second derivative as the one that's shown right here, and it's just minus 2. And since minus 2 is less than 0, we know that it is in fact a maximum. So remember, if the second derivative of your function is less than 0, it's a maximum. And if it's greater than 0, then it's a minimum. You will likely always be asked to do that check in your questions. So let's go back. So we found that the width is equal to 50 and the length is equal to 50. So that means that in order to optimize this function and find the maximum area, it is best to ensure that it is a square. So both length and width are of the same dimensions. So I hope that helps you guys find the process of optimizing a little bit easier. And if you have any doubts, or if you're looking to practice some questions, then you can refer to one of our videos. Thanks very much.